Saya Dr. Syamil.
Syamil, satu kali bracket, satu square bracket.
Oh.
Betul lah tu, cuma betulkan square bracket tu.
Okay.
Okay, thank you Haris. So macam what Haris did is correct, cuma sini kena letaklah VM kat depan. Sin omega M. Okay Haris, macam tu. X2 is a X kecil lah sepatutnya, alright? Okay, so you can see what happened to your, okay, dah ya? Alright, so you can see that what happened to your frequency and amplitude of your signal after it is being modulated. So this part, okay, your amplitude becomes half and your frequency of the modulating and the carrier are being modulated. Okay, so you see here, you can see here, this is the VC sin omega CT that we already from the first component, which is the VC here, multiply with this sin omega CT, and then you plus with, after you already multiply the sine and the sine, you get half of your VM, okay, cos your carrier and your modulating frequency are being for minus, and then here being add up plus. Okay, please be careful, there is a big bracket here, there is one bracket here, that means this VM is for both components. This component, this is the lower frequency, the higher frequency, both will be half VM. Okay, so this one I open the bracket. So don't forget, this one has a half VM, this one also have the half VM. Okay, so if you do one bracket, then you need to open up lah. Okay, I repeat it again here. So what happened after that? I don't know if my project can highlight or not. Cannot highlight. I want to highlight here. I choose the size so it becomes one. Okay. Okay, so this is half. I open up this one, half, and then if you can see, this is the carrier frequency. This is the modulating frequency. So omega in frequency, if you minus, that means you go to the lower frequency. Get it? Okay, so this is the original carrier frequency, but this one after you deduct with the modulating frequency, it will be at the lower frequency, lower side, lower band, yeah. And this one is omega C plus omega M at the higher end. So this is the low band and this is higher band. Okay, higher frequency and the lower frequency. This is your carrier at the middle. Okay, in the middle you have your carrier. So there are three components that you see here. So this is the lower frequency component, this is a higher frequency component, this is the original signal. So if you see that this is, although we open up after the AM, this is VAM. After you open up, you will still have the carrier signal. You see here? This is your carrier amplitude and frequency. So if you see that our original signal, this is our original signal. We see sin omega CT, your carrier signal. Okay, we see sin omega CT, and after you open up the VAM, you still have your carrier signal. Okay, so it's just additional of a sideband. This is what we call it sideband. Okay, lower sideband and upper sideband. So, but the sideband amplitude is half of your VM, okay, which is your modulating signal, half of your original modulating peak signal. Okay, so there are three components here: the carrier, the upper side, and the lower side. So the carrier frequency remain as omega c. So omega is in radian, and the upper frequency is the one that is add up between your carrier frequency and the modulating frequency, and the lower frequency would be the one that is minus of the carrier and the minus from of the carrier and the modulating. Okay, got it? So what is the bandwidth of the signal? Okay, can you there are three bands. Okay, there will be three bands like this. So one is the omega c, which is the carrier signal, and one is the upper side frequency, and one is at the lower frequency. So what is the bandwidth? If you can catch what I showed earlier. So bandwidth, remember, bandwidth is between the lower frequency up to the higher frequency. So can you tell me what is the bandwidth? Yeah, the difference, upper tolak lower. So the upper frequency is, you can write down omega c plus omega m, and the lower frequency is omega c minus omega m. So you tolak lah, you minus those two, you get tadi Amni typing dah hilang dah. Amni was typing, Haris was typing. Okay. Alright, very good. So the bandwidth is 2 omega m. Remember, omega m is the frequency of the modulating signal, not the frequency of the carrier, yeah? So the bandwidth is the 2 times of your modulating signal frequency. Okay? Okay. So here the bandwidth is the difference between the highest and lowest. You minus those two, you get 2 omega. So the unit is radian per second. So you know how to convert lah later, yeah, for between the radian and the frequency. Okay, so this is how it looks like, the bandwidth. Okay, as what we already showed you, it becomes a one peak only for one frequency. So this is the upper frequency and the lower frequency. And remember, the amplitude of this carrier is, what is the amplitude of the carrier? Okay, and the amplitude of the sideband, we call it sideband, the left and right. Okay, thank you, Iza. Very good. Okay, so the amplitude you can write down on your own, yeah? So you draw the diagram. The amplitude here is VC, and the amplitude for the sideband are VM over 2. Okay, so we already did for omega C. So basically it's the same for it's easier if you do it in terms of frequency. Okay, so the omega is 2 pi f. So you want to find the frequency, you just divide your radian, divide by 2 pi. Then you get your frequency. So it's straightforward. Omega C plus omega M, you convert to Fm plus Fc or Fc plus Fm. And omega C minus Fm is Fc minus Fm. Okay, so this one unit, the unit is Hertz and the omega is radian. Yeah. Okay, this is something. This is not related to this diagram. This is just an example of a spectrum analyzer output. Okay, so if you we have a spectrum analyzer in our lab, one only. So it's that you can see this if you happen to do later on your final year project ke master ke. So you will use a spectrum analyzer, then you can see something like this. Okay. All right. So we go to the next one is modulation index. Modulation index is change of the amount amplitude change in the amplitude modulation waveform. So M, please write down on your notes, because later on your FM also will have a modulation index and it will be different. So the name are the same but the formula are different. Okay, so for amplitude modulation, your modulation index is the voltage of the modulating signal, which is your information signal, divide with your amplitude of the carrier. Okay, amplitude of the carrier is, you can also say, unmodulated. So because the unmodulated is the original signal. Okay, this is your unmodulated signal, origin signal. Okay, and then after you modulate, you get your amplitude modulation signal. Okay, so the modulation index, okay, this is original, this is your unmodulated carrier and unmodulated information signal, which is your modulating signal. So the M is Vm, which is your amplitude of the modulating signal, divide with your amplitude of your carrier. Okay. Remember the M at the top jangan terbalik pula, VC over VM. So it's VM over VC. Okay. So this is what you will get when you do the amplitude modulation. Okay. You can snapshot ke, if you can draw on your own, that this is amplitude modulation wave. After modulated, this is a modulated wave, amplitude modulation wave. Okay, so your VM, okay, the peak here is your VC, amplitude of your VC plus your VM. And the minimum is the one VC minus VM. Okay, take note of these two. And the difference between, you see here, this is your maximum and this is your minimum. So the difference here are your the maximum here is your VC plus VM. You cannot, if you deduct these two, you cannot get it will not give you anything, because your VC is not exactly the minimum. This is the minimum. You see here, VC is in the middle here. It's not, you cannot use that to find your VC. You need to do the equation later on using the V minimum and the V maximum. Okay. Okay, so what we can say here, this is the Vmax. You see here, this is the Vmax, and Vmax is Vm plus Vc. Okay, and the same thing as your negative. It doesn't matter lah, plus your positive or your negative, but both are total of your Vc plus with your Vm. Okay. What are you going to do with this? Let's say you have this equation. How are you going to? Okay, normally this equation, that means, for example, we give you the amplitude of this wave. Let's say the maximum here is 10. What is the axis? What is this y-axis? Okay, thank you. Amir, you want to write something just now? Najihab? Okay, thank you. Right, so back to our wave. This is, let's say the maximum is 10. And the minimum is 7. Okay, let's say this maximum is 10 and the minimum is 7. Although it's not, it's not half actually, but just assume that it's 7. Okay. So can you calculate what is the Vm and the Vc from this all value? Anyone? Vmax is Vc plus Vm. Vmin is Vc minus Vm. How to get Vc? Oh, okay. How to get Vc first lah. Plus, how to get Vc? Give the thank you Nohaila, give the equation. I don't want the value. Okay, Amir Faris, Vmax minus Vm. Okay, in this case, we are given the graph only. You are given the Vmax and the Vmin. We are not given the Vm and the Vc. You have to find that out. So you just given the graph, you have to find it. So using the max and the mean, you can find the first is the Vc. Vc plus Vm is 10. Yes, Vc plus Vm is 10 and Vc minus Vm is 7. Yes, but what I mean is the equation in terms of Vmax and Vmin. I have 32 students in my class. Okay. Okay, Fauzi said half of your Vmax minus Vmin. Wait for Haris and Levin Raj. Okay, Nuhaila and Haris said Vmax plus Vmin. Okay, let's look at the equation. Okay, dah? Any more typing? Alright, if you look at the equation, Vmax is Vc plus Vm and Vmin is Vc minus Vm. So if you add these two, you get Vc plus Vm minus we go for additional. Vmax plus Vmin. So Vc plus Vm, you add with Vc minus Vm. What do you get? You get 2Vc. Correct or not? Because your one is the Vmax is plus Vm here and your Vmin is minus Vm. So when you add up these two, you get your Vm will be gone because one is plus, one is minus. So Vm will be gone. So Vmax plus Vmin, you get 2Vc. So who answered that? Okay, Haris and Nuhaila. So Vc you get is half of your Vmax plus Vmin because when you add up both, you get 2Vc. Your Vm will be removed, deduct together, and then you get this Vc plus this Vc. Okay, you get 2Vc. So Vmax plus Vmin, you get 2Vc. Therefore, Vc is half of your Vmax plus Vmin. So the other way around, you can get your Vm by deducting between the max and the min. So Vmax minus Vmin, you get your Vm. So half lah. You need to solve the equation. I didn't give you the answer that Vmax minus Vmin you get Vm. You need to figure out using the Vmax and Vmin, deduct both together. Okay. Okay, good. Right. So we go to the next. We're not going to do example today. We just straight away with the theory. So I'm preparing you for the lab. So for your lab, you need to you will get this graph Then you need to find the amplitude modulation. And then the next will be the power. Okay, so this is just some theory. You have to, modulation index is M. Your, what do you call that? Percent modulation will be times 100. Okay. So is M is 5, 0.5, and the how much is it being modulated is this 50%. So if your answer is 1.0, that means it's 100% modulated, and normally it is your modulation index would not be more than 1. If it is more than 1, your signal will be distorted, over modulate. Okay. Right. Okay. This percent modulation. Sorry. So percent modulation is your modulation index times with 100. So the one that I already gave example earlier. So M is 0.5. Your percent modulation will be 50%. Okay. 100% is 4. M is 1.0. Okay. Next is power. So for power, let me see for your lab. So basically lab will be your modulation index and between the amplitude and the modulating signal and the carrier signal. Okay. You have to identify which is the carrier. The carrier is normally the one which is higher frequency, and your modulating signal, which is your information signal, will be the lower frequency. Then you modulate, and then after that you get your VAM signal. So tomorrow you just do theory, simulation, for the lab, yeah. All right, for the power. Okay, we just do the theory today. We may do the example on the next lecture on Friday, yeah. Okay, so as I told you, this is for amplitude modulation. Okay, sorry, this is not noise. Okay lah. All right, so you need to recall back. Okay, please be careful, yeah. The one that you normally we normally learn, P is equal to VI, and then V squared over R. That is the RMS value, root mean squared. Okay, so the relationship between RMS and peak. Okay, so your RMS is your V peak divided by SERT2. So please remember that our graph and our original signal are all in terms of peak. Okay, where is it gone? Is it there? Okay. Recall back that your original signal, because we gave you the in terms of equation, so that is the peak, yeah. So this is the peak, and this is also the peak. Okay. So we are going to play around with the peak value. So V squared over R is actually RMS value. So you have to change your RMS value to V peak, because this V peak will the one that you can take the value from the equation given. You'll be given the equation. If even the graph that we did here, this will be giving you VC, VM. These are all the peak value. Okay. So that's why you have to change from the RMS formula to the peak formula. So if you put in, replace your VRMS with the V peak, you have the V squared, and your power is P is V squared R. So VRMS squared, you get V peak squared over 2. So that at the end, you have 2R in your power because we use V peak. Okay. So P is the carrier power. Okay. Okay. Here the equation is given in terms of peak, but so this is actually we pick for carrier because this is a carrier power. You got it? So I'm going to copy this. So this is actually, I need to copy the whole thing. So okay, you can write on your own, yeah. You write this, PC is V squared over R, V is VRMS, and then equal to V peak over V peak squared over 2R, and this V peak is your VC. I want to copy this, it takes, because this is equation. You cannot just simply change. Okay, so this V peak class, please be careful, yeah. This is carrier power. Okay, so for the carrier, if this is carrier, therefore this voltage is your peak of your carrier, VC. This is your VC, the amplitude, your VC, because the equation that you have, that is the peak. Okay, this is peak. So this V peak in the equation is your VC. You can straight away put in the VC, but remember when you put this VC, there is a 2R. Okay. Any question? Faham, ya? Because we have you have to understand this power calculation because we're going to use this a lot in terms of when you do the drawing, when you calculate the power, so you need this equation. So please remember there is a 2R at the bottom. There's a 2 at the bottom. Okay? Don't forget this. Your answer will be different if you don't have this 2. Okay, so take note of that. Write in your notes, yeah? Okay, so this is the carrier power. Remember, your carrier is at the center. But for this carrier, this is your carrier band. Okay, so this is the upper side band, lower side band. So this is the carrier. That means that PC that we calculate earlier is the power for your center band carrier. Okay, so you also have, so this is the carrier power. So you also have the sideband power. Okay. Remember your sideband? What is your sideband? Sideband amplitude. What is the sideband amplitude? Okay, VM over 2. Thank you. All right. So, can you, what is MM is VM over VC. Excuse me. What is your VM? VM is MVC, correct? Because your M is VM over VC. VM is MVC. And your amplitude of your sideband is half VM. Therefore, your equation becomes half of MVC. Got it? Oh, sorry, this is a picture. M is Vm over Vc. So Vm is MVc. Okay, and your amplitude sideband is half Vm, therefore half MVc. Okay, so that is what I put here, MVc. So originally, this is actually M half Vm over 2R. Right, yeah? Okay. Yeah. Okay, class? So actually the side power for the sideband, the same formula V squared over 2R. It's just that your Vm, your V squared to your because the amplitude of your sideband is half Vm. So remember that you have to bracket because you have when you have half squared. Okay. So this Vm we change with the MVc. Okay. Got it? So that is why your sideband is MVc over 2 squared and then divide by 2R. So this is actually half Vm. Okay, this part is half Vm, your sideband amplitude. Okay, and then you open up the bracket squared. Please be careful when you open up the bracket because you get M squared Vc squared over 2 over 2. 2 squared 2. That means 4. Okay, so when you open up, you get at the end M squared over 4 of your PC. Because why we did this? Because we want to relate it with PC. This is VC squared over 2. This part is PC. Okay, so if you don't want, it's better if you also know how to get this equation from the original, which is half Vm squared. So add in this in your notes. Yeah. So P sideband is half of Vm. Everything is squared over 2R. And then you work out the answer from here. So if you're not given the Vm, you can find the Vm from the M and Vc. Okay. If you have the Vm directly, then you just put in the Vm lah. Alright. Okay. So this equation that given is just to relate between your carrier and your sideband. This is your sideband. So this is the power for the sideband. okay, in relation to power of the carrier. So by right, your power of your side power of your sideband is this, half Vm squared over 2R. Okay, and then you solve from there. But if you want to relate with, if you are given the power of the carrier, you can just calculate directly if you know the modulation index. Okay. So this is sideband. Remember, you have two sideband. One is the upper sideband, one is the lower sideband. So the total power for the amplitude modulation will be your carrier, which is the center, and the sideband. This is the lower sideband and one upper sideband. You have two sideband, yeah? And at the end, you have total power is given by PC 1 plus 2 m squared over 4. Okay. All right. Not going to do this example. We do example more tomorrow, yeah? I mean on Friday. All right. So if you have several modulation index, you add up the modulation index by square root of squared for all the modulation index. This is just example, how to calculate the total modulation index if you have several. But you're not going to do that for in our lab, yeah? Okay, straight away, so we'll, so this one is also something to do with your power, your maximum power. You can look at the notes later. I'm going to do for the circuit then, because you're going to do the lab. Okay, so this I'm going to discuss the advantage and disadvantage later for amplitude modulation when we do the towards the end or at the beginning of your frequency modulation. You need to compare between the amplitude modulation and the frequency modulation. So this is an example of amplitude modulation circuit. So we use transistor. Okay, you remember that you have two inputs, which is the one is the carrier and one is the audio. Audio is your information signal, which is the lower frequency. So you input your audio at the emitter and your carrier at the base. Okay, put in the values, then after that you simulate to get the output at the collector. Okay, so because normally you have your V out here kan, from the transistor, so you take the output at the V carrier. Okay, sorry, the collector. Okay, so there are several circuits you can find in the internet as well. So, but basically, you need to be careful. You can try for the lab. What? Because it's a simulation lab, you can try to put in the value for the audio frequency. You adjust the audio frequency. Try to, if let's say you put high frequency here, low frequency here, what happened? Okay, you can play around with the circuit because you do simulation. Okay, so by theoretically, your high frequency carrier is input at the base. Okay, and then your audio signal is at the emitter. Okay, so you need to put in the value of the voltage division. Okay, because your audio and your carrier are AC signal. Yeah, the equation that we did all this while is AC signal because you have a amplitude with the sine and frequency wave. Okay, so you have the modulator. This is the modulator circuit and the demodulator circuit. Demodulate is when you demodulate your modulating signal. So this is modulating signal. So when you demodulate this signal, you should get back your original signal, which is your carrier and your modulating signal. you may not get exactly as what you expect, because it will be noisy, very noisy. Okay, but somehow at least you can see there are two frequency, and although something like distorted, but at least there are two frequency output, okay, that you get from the demodulated output signal. Okay, so you input your MAM, the modulated signal, you get back your audio signal. Okay. All right. So any question? So for your lab tomorrow, you please you can find lah the circuit for your amplitude modulation. Okay, but basically I gave you the idea already. Your frequency, your carrier is higher frequency with modulating signal of the lower frequency, and then you will get the modulating signal. Okay, question: Do you have a multimedia system this semester, right? If I'm not mistaken, you use.
Yes, doctor. Use Scilab. We use Scilab.
Scilab. I need the Scilab. Okay, so you need the Scilab for the to do the amplitude modulation. Okay, so I will give you the code for the Scilab. You put in into the notes, and then you will get your modulated signal output. At least you get some theory signal from the Scilab. Okay. After that, I'm going to give both the Scilab and also the simulation for the circuit. If you see how it goes for the simulation circuit, yeah. Everybody has submit your oscillator lab.
Not yet, doctor.
Okay, let me see your lab 1. You have not submit lab 2 eh? Okay, for lab 1 and lab 2, please be careful when you select the value. Mostly, please use Scilab. MATLAB later, you already know MATLAB. MATLAB later, probably next week we do noise, then you use MATLAB. Okay? Please use Scilab for amplitude modulation. Okay. For the lab, your filter lab and your oscillator lab, what you did is the simulation. So you need to, because later on week 6, 7 onwards, we're going to have face-to-face lab. Okay, so face-to-face lab, we're going to use the value of what you already designed. Okay, so the value must be reasonable value lah. You cannot choose frequency the resistor too high or value that is not in the lab. Okay, so because you're going to implement it in the lab for the filter and oscillator. Did you get your filter response, frequency response? Abdul Rahman Hajo, I told you no need to put in the introduction, you procedure everything, you put in again. Just give the result. Okay, you have the result but you don't have the design. Okay, please show your calculation, yeah? How you did the calculation to get all the values. And each of your diagram, please give you need to put in the R and C value. You cannot just simply say R increase, R low, reduce. So you must be specific R value. What is R? Is it 10 kilo? What is C? And so on. Okay. For the previous lab, Mosi, your filter lab. Because you already submitted your filter, so only filter that I can see. So when you do any result that you put in your report, please put the specific R, C, and L value. Okay, because you may when you do simulation, we may try a few values, and then you can get a good result. So those results that you submit in your report, please put in the R, the C, and the L value for each of the diagram. Okay, and those value, please you're going to use for the hardware later on. Okay. Also class, your lab report, please keep, yeah, because at the end of the semester, when I see you face to face, I may ask you the hard copy. Okay. So for the, no, mostly not next week. I said later on. Next week we still have simulation, but we do noise simulation. Noise simulation you will be using MATLAB, yeah? So you already know MATLAB, kan? Okay. All right. So any question? For your lab, AM lab, I'm going to give you the code for the AM using Scilab. There will be the frequency of the carrier and also the modulating frequency. You can modify the frequency and the amplitude as well, because I already showed you how to calculate M, VM over VC. So that's why I asked you to write down, because I'm not going to give you the slide yet, but you're going to do the lab tomorrow. Okay, so your modulating signal M is modulation index is VM over VC. So in the code, you will have the carrier signal in terms of VC sine FC 2 pi FCT. Okay, so the amplitude and the frequency of the carrier, and also the amplitude and frequency of the information signal, you can modify and then use to calculate your different modulation index. So you put in something like 0.5 to get M is 0.5, to get M 1.0, to get M 1.5, although it is over modulated, but you can, because it's a simulation, kan? So you put in the value and then you see the different waveform between the normal modulation, the 100% modulation, and also the over modulation. Okay, so that is the first thing that you do first. Then later on you may need some time for the AM circuit. I I may give you time, because later on when we do the hardware, we are going to do the AM modulation hardware circuit. So this AM design, the one that you already did filter, you did oscillator, and then this one is AM circuit. Probably we will do this for your face-to-face hardware lab. Okay, week 7, mostly week 6 or 7 onwards, I will inform you. But for this week and next week, we still do simulation lab online. Okay.
Doctor, when we do the hardware lab, do we have to submit the lab report again for the hardware?
No, hardware will be hardware lah, different lab report. You just compare between your simulation and the hardware.
Okay, doctor. Thank you.
All right. Okay. Any other question? Almost 2 hours already. Any question? Ada ya? So you good for lab tomorrow, yeah? So again, I just want to remind you for the value of your, please be realistic, yeah? Your RLC value for the oscillator, okay? Because you're going to do that for your hardware lab later on. All right, so that's all for today. If there's no question, then I'll see you tomorrow. If you can do on your own, you don't need online. So I'll see you on Friday.
Okay, Doctor.
Alright, thank you. Assalamualaikum. Selamat berpuasa. Selamat berbuka. Pukul 7 nanti 7:30 nanti.
Selamat berbuka, Doctor.
Alright.